Okay, guys, I have a lot of things to go over today. The first thing we're going to do is look at this particular diagram. In this diagram, there's a lot to be seen. First of all, this A is across from little side A. The way that I label the sides, I could call this side BC, but it's kind of a pain to constantly be writing overlapping segments. Like BC is a segment, AB is a side of a triangle, AC is a side, and it's very confusing. What's easier is to just simply say across from angle A is little side A. And across from the middle angle B, B is the second biggest angle, is the second biggest side. The smallest side is across from the smallest angle. This is always true for all triangles. The biggest angle is across from the largest side, which in a right triangle is called the hypotenuse. These are called the legs. They're on the right angle, and this is a right triangle. We usually traditionally call it ABC, just because that's the way we write the Pythagorean theorem. The Pythagorean theorem says if we have a right triangle, then a squared plus b squared equals c squared. The sum of the squares of the legs is equal to the square of the hypotenuse. That's how you say it. One thing I'm going to go over today, and I highly recommend that you write it down in your margins. I'm going to go through the 5 problem-solving steps. They are going to be the same for the next 5 or 6 years of math, science, physics, engineering. All of those classes are going to use these same 5 steps for almost all the problems. I used to do a demo where I had a shelf of math books and chemistry and physics books. I would pick one at random, open it to a page with problems, and show you that this was the steps you follow. I will do that later in the year. The first step is to draw a diagram. Did you do that? Everybody has a diagram? You should have a diagram of this triangle. The next step is to write the formula or maybe an equation. We've got a formula here. Your next step is to substitute inside parentheses. I'm going to write it that way. Substitute inside parentheses. I don't have a number for A, so I just leave A alone. But I do have something for B. What should I put instead of B? This is A, and it's across from side A. So which side is B? How big is side B? Yeah, it's the 4. This is side B. The legs are A and B. Sorry? Oh, I'm sorry. 4 squared. And C is the 5. We're just substituting inside parentheses. It's always a good idea when you substitute to put parentheses around it. Then we simplify. When we simplify, you want to follow order of operations. So a squared can't be simplified, but 4 squared can. What's 4 squared? 16. 4 times 4 is 16. And 5 squared? 25, yeah. Notice that I'm following these steps. Later in the year, when we get to really, really difficult problems in geometry, and they seem impossible, you're going to be able to follow those steps, and I promise they're going to work every time. The last step is to solve. And we're going to solve it for A. So we need to get A by itself. What do I need to do first? Minus 16 on both sides. Yep. And you get A squared by itself is equal to 9. Now, when I'm solving, I do the opposite to both sides. The opposite of squaring is called taking a square root or a radical. We're going to take the square root of both sides. And what's A? Square root of 9 is 3, because 3 times 3 is 9. These three sides on a triangle always gives you a right triangle, 3, 4, 5. It has a name. It's called a Pythagorean triple. 3, 4, 5. It's called a Pythagorean triple. There are lots of these, and in fact, I was teaching for about 12 years, and I ran into another math teacher at a conference, and he taught me a really cool theorem about Pythagorean triples that I had never seen before, and we proved it together at that conference. It was really cool. I'll be teaching it to you later this year. It's really, really useful, kind of hard to understand, but later on we'll deal with it. Today, we're going to do the converse of the Pythagorean theorem. Now, this is the Pythagorean theorem. If I have a right triangle, or a triangle has a right angle, that's called the hypothesis. If this is true, then I know the conclusion. This is an if-then statement. This is the conclusion down here. If I have a right triangle, then a squared plus b squared equals c squared. Can you guys turn that around? If a squared plus b squared equals c squared, then I have a right triangle. That's called a biconditional statement. It works both ways. Not everything does. Some things only work one way, but this one works both ways. Now, what we're going to do is I'm going to show you how this works, and we're going to do all the corollaries of it as well. It sounds really difficult, but it's not. What I'm going to have you all do, you are going to construct a triangle that has sides 6, 8, and 10. So at the very bottom of your paper, you should have about maybe a half a page left, maybe a little less. Doesn't matter if it's less than a half. As long as you have about this much space, you're okay. We are going to construct a 6, 8, 10 triangle using side, side, side. We're going to use the three sides of the triangle to make it. We don't know any angles, and we don't have to know any angles. All we have to do is make our three sides. And we're always going to start with the longest side. So if everybody would draw a segment 10 centimeters long, most of the way down your paper, like right about here, maybe here, make it 10 centimeters long. Now you'll notice that mine is the second half of the ruler. So I have to measure, I have to think about my measurement a little bit. I'm going to go from 17 to 27 to get 10 centimeters. I need 10 centimeters. You can go from 17 to 27. You can go from 18 to 28. You can go from 19 to 29. It doesn't matter as long as you have 10 centimeters in there, right? Okay. This is 10 centimeters. Hopefully all the compasses are working still. I literally spent an hour this morning taking all the compasses apart, sharpening all the pencils, adjusting all of the tension on them. So they should all work. If you have one that doesn't work, let me know and I'll fix it. What we're going to do now is I want you to open your compass to 6 centimeters. I'm going to go from 20 to 26, however you want to open it, 6 centimeters. So get 6 centimeters on your compass. It should look something like this. Y'all see it okay? Mine, I'm going 10 to 26, or 20 to 26, excuse me.
We have like 6 centimeters?
6 centimeters, right. Now you have your segment that's 10, right? You have a segment that's 10. Now I want another side that's going to be 6 centimeters. The problem is I don't know where it is. It could be anywhere on this arc, couldn't it? You'll see what I mean? That the segment could go anywhere on the arc. So I'm going to draw an arc that's 6 centimeters long. This is the radius. See, this is 6 centimeters right here. Can anybody see it? That it's following the 26? See it? It's 6 centimeters. Everywhere on that arc is 6 centimeters long. How long am I going to make the other side? 8 centimeters.
Oh, 8 centimeters.
So from the other side, we're going to measure out 8. I'm going to go from 28 to 20. And I'll put it right here so you can see it. Can everybody see my 28 to 20? Not quite. Or 20 to 28. I'll turn it around so it looks better. 20 to 28. I'm not quite there yet. Come on. I adjusted them really hard, but it's horrible when they flop around on you. It's really hard to use them. Okay, 20 to 28. There we go. Everybody have 8 centimeters? Got it? So from the other side, we're going to mark the 8 centimeter side. And we know that it's somewhere on this arc, and clearly it's going to be where they intersect, isn't it? Y'all see this is 8? And the other side is 6. This one is 8 on this arc, and the other side is 6. So we've got a triangle here. And it may look like a right triangle. Let's see if it is. I'll put my measurement on here so you can see it. Can everybody see it's 6 centimeters here? 20 to 26. That's 6 centimeters right there. The other side is 8. 20 to 28 for me. Some of you have the nice side of the ruler. You can go from 0, right? Makes it a little easier. There you go. Now, when you're looking at my picture up here, it's a little bit distorted, and it doesn't look like exactly like a right angle. It looks more acute. But if you look on your paper, you can see that this looks like a right angle, doesn't it? The thing is, we can't be sure until we check the converse of the Pythagorean theorem. We want to know, does a squared plus b squared equal c squared? And if it does, we have a right triangle. So put it in. Does a squared plus b squared, now we don't write it equal because we don't know if it's equal yet. We want to know, is it equal to c squared? This is the question. How do they compare? Let's see. A is 6, B is 8, and is that equal to 10 squared? Do you see we did the opposite of what we did before? Before, we had a right triangle, and we said that this is true for right triangles, and then we used it to find a missing side. In this one, we have the 3 sides of a triangle, but we want to know, is it a right triangle? Is it true? Is it equal? 6 squared is 36. What's 8 squared? 64. Is that equal to 10 squared? It's equal, right? This is true? This is equal? Then this is a right triangle, for sure. And in fact, you may have noticed, I don't know if you did or not, that 3, 4, 5 doubled is 6, 8, 10. You could triple them, and you're still going to have a right triangle. It'll just be 3 times as big. If you make them 4 times as big, 5 times as big, these will always make right triangles. That's why this is so helpful to know. 6, 8, 10 is a right triangle based on the converse of the Pythagorean theorem. A squared plus b squared is equal to c squared, so this is true. Now we're going to do what's called the corollaries. The corollaries go from here, and we make something extra. We're going to do 2 more triangles. If you would, on a separate page maybe. If you didn't get 2 papers, don't worry. You can just put it on the back. Let me grab some blank paper here. we're going to make a 6, 8, 9 triangle. 6, 8, 9. And we're going to construct it, same as we did before. Start with the 9. Seriously, guys, let's go. Come on. Keep in mind, folks, this is my 5th time doing this. I could just record it once and make you watch the head puzzle, but I don't want to do that. Do your 9. Start with your longest side, okay? Now, when you do your Ed puzzle, there's an Ed puzzle on this, but it's this other guy, and he does not start with the longest side. I think it's always better, though. Let's go to the longest side. It's going to be 9 centimeters. I'm going to go from 17 to 26. That's going to be 9 centimeters. I could go from 20 to 29. That's just as easy. There it is. That's 9 centimeters for this side. And you're also going to do a 6 and an 8. Now, the nice thing is my compass is still on 8. Is yours still on 8? I didn't move mine, so it should still be on 20 to 28. There it is. Got him? Go ahead and move him back. Mine's just a little too long. Let me fix it. 20 to 28. Yep, there it is.
8 centimeters, right?
Yeah, I'm gonna go on this side with the 8 centimeters. It doesn't matter. It'll work either way. It'll just turn it around. This arc is 8 centimeters. I'll make it a little darker so you can see it. And what am I gonna make the other one? 6, just like the other one, except for this time, instead of 10 centimeters, my longest side is only 9. Yeah. This side over here is only 6. And you can see my measurement, hopefully. This is from 20, oh, that's 22 to 28. Here's 20 to 26. You all see it? That's 6 centimeters over here. And this one's going to be 8 centimeters over here. This one doesn't look like a right angle, does it? What's it look like? Acute. It looks like it's an acute triangle, doesn't it? Because this biggest angle, everybody notice that the biggest angle is across from the biggest side? That's an important idea. This is definitely the biggest angle on the triangle. And it looks like it's acute. And I want to show you a couple of reasons why. Does everybody understand that if this was 10, that it would be a right triangle? 6, 8, 10? Yeah, but it's too short. So what happened to the angle? It made it smaller, didn't it? That make sense? That if instead of 10, it's 9, it's actually smaller, so it made this an acute triangle. To test it, all you have to do is put it in the Pythagorean theorem. A squared plus b squared, and compare it with c squared. The nice thing is we already know the 6 and the 8. We already know what 6 squared plus 8 squared is. This is 36 and 64, so it's still 100. Hasn't changed, right? 36 and 64 makes 100. And what's on this side over here? 81. Now, I want you to remember this because everybody gets this backwards about the first 3 or 4 times they do it. I am interested in this side only. If this side is too small, in other words, the C is too small, it makes an acute triangle. All 3 sides are different. Remember what that means? All three sides different. It has a name. Scalene, yeah. This is an acute scalene triangle. I know it's scalene because of the three sides are all different. I know it's acute because the C is too small to make it a right triangle. That's a corollary of the converse of the Pythagorean theorem. There's one more. Try 6, 8, 11. You can probably guess what's going to happen, but give it a shot. Go ahead and draw it. I'm going to put my 11 first. So I went from 16 to 27, which gives me 11. I could also go from 17 to 28, or 19 to 20, 18 to 29, or 19 to 30. They all are giving me 11 centimeters. And then I'm going to do my 6 and my 8. I think this one's 6 right now. And it is. This is 6. Here's my 6 arc. This is 6 centimeters right here. Hopefully you can see it. That's my 6. I'm going to open it to 8. There it is, 20 to 28. I'm going to go from the other side. This is called a side construction. Notice that I didn't put any of the angles on the triangle. I didn't measure any of them. And yet I still get the same triangle as everybody else. This is 6. And this one is 8. And let's put it in our comparison. A squared plus B squared, and compare it with C squared. All right. We've got 6 squared plus 8 squared. Still 100, hasn't changed. Over here we have 11 squared. (11 squared, 11 times 11? 121. This means that this side is too big and the C is too big. That means that this angle is what kind? Obtuse. This is an obtuse. It's also scalene because all the sides are different. The nice thing is we don't have to make the drawing in order to do this. All we have to do is check the A squared plus B squared and compare it. If you have some space, we're going to do some examples. I'll just put them in the back here. Our first one's going to be 5, 5, 7. I want to know, what kind of triangle is this? Guys, before you ever do anything else, can you tell what kind of triangle it is? With two sides equal? It's based on the sides. Two sides equal. Remember? If no sides are equal, it's scalene. If two sides are equal, isosceles. This is isosceles. Now, we're going to use the A squared plus B squared and compare it with C squared to see what kind it is. If we were to draw this, you still wouldn't be able to tell because it's really close to 90. Let's see. 5 squared plus 5 squared, and we're going to compare that with 7 squared. Try it. Don't wait for me. Sorry, this is square here. I know it's kind of getting a little faded out. Okay, what's 5 squared? And 25. This side is 50. What's this side? Okay, now here's the hard part. Is C, remember we're talking about side C. Is it too big, too small, or just right? Y'all see it's too small? What kind of triangle is this? If C is too small, it is isosceles, but what about the angles? Acute because C is too small. Barely. Does everybody see it's going to be really close to 90? No, if it's above 90. 90 is the key. 90 is just right. Acute is smaller than 90. This is going to be about 89 degrees, guys. It's going to be really, really close, but it is acute because the third side is too small. If you were to look at it, you wouldn't be able to tell. If I draw a 7-7 triangle with a right, it's going to look like it has a right angle in it. See that? The 5-5-7. It looks almost like a right triangle. It just happens that this is about 89, which is going to look right, but it's not. It isn't acute. Okay, try 5-8-9. 5-6-8. Let's do that one. 5-6-8. 2 more. Put them in. Sure. Is that better? Plus 36, and we're going to compare it with 64. What's this side over here? What's this guy? 36 and 25? Okay, now here's where everybody runs into problems. Don't forget that the thing you want to think about is how big is C? Is C too big, too small, or just right? C is too big. That means that this is obtuse. And it's scalene. All right, one more. Okay, obtuse, and I wanted to show this, and I didn't do this before. I'm sorry, guys. I meant to do this earlier. Here is, I just want to show you something. This happens to be 6, 8, and 10 units. You guys will have an opportunity to do this when we look at triangle inequality. But I want you to notice that if I put these together, that I pretty much get a right triangle. Everybody see it's a right angle there? I know mine's a little distorted, but it works pretty close. Now watch what happens if I put a smaller side for the longest one. This is still the longest side, but it's going to be smaller. Now watch what happens when I have to put these together. I have to bring this one in, and notice what's happening to the angle. Isn't it getting smaller? Less than 90. Again, if this is a bigger angle, if this is a bigger side, I have to make the angle bigger to make it work. Got it? What if the side's longer? Take a look. Oh, this one's longer. Now, to make this match, I have to make the angle larger so that it matches those two sides. This is obtuse. When the third side is too big, it's obtuse. When the third side is too small, it's acute. And when the third side is just right, you have a right triangle. Okay. One last one. 5, 12, 13. That's you. 5 squared. What's 12 squared? 144. 13 squared. That's the 169 over here. How did they compare? Just right, yeah? Just right. This is a right triangle. Because, and by the way, this is your other Pythagorean triple. You will see it very often. SAT loves this one. The 3, 4, 5 and the 6, 8, 10 they use sometimes, but they always use this one because it's not that obvious. The 5, 12, 13 is a favorite. Watch out, this is a right triangle. We just have one last one, and it's a trick. 3, 3, 7. Okay, give it a shot. If you just stick it in the formula, it's going to look like it's an isosceles obtuse, isn't it? Look at it again. That's what it's going to look like. That isn't what it is, though. Anybody see the problem yet? I'll show it to you with straws. It might help. Here's a 7. Here's a 3. Here's a 3. You can't make a triangle out of that, guys. It's never going to work, is it? There's a thing called the triangle inequality. What it tells you is that if these two sides aren't long enough, there is no way to make a triangle out of it. Does that make sense? Do you see how it's going to trick you? Watch out for those. This is not a triangle. Even if I make them the same length, even if I do this, if I make it 3, 4, 7, it's still not a triangle. It's just a segment. They just sit on the same, you see, they just sit together. So they end up looking like this. Here's 7, here's 3, here's 4, here's 7. There's no triangle. It's just a segment. Not a triangle. Be careful. Sorry? It would have to be, yeah, this would have to be like anything bigger than these two, you'd be all right. Like I could make this 4.1 and I'd get a very thin triangle, but I'd get a triangle. As long as these two sides are bigger than the other one. Have you guys ever heard the expression, 2 heads are better than 1? Okay, I use this one, 2 sides are bigger than 1 in all triangles. That's always true. So take the 2 smallest sides and add them together. They have to be bigger than the other one. You have a quizzes today. You do have more than one opportunity to get 100. Hopefully you'll do it right away. There's some hints up here. This one is from last period. Let me get some. Help each other. I put them in the same order so you guys can work together on them. Yeah, nice easy quizzes. Where'd he go? Where'd he go? Oh man, I'll have to get another one. There it is. Oh, they're still running. I got to turn them off. Okay, let's see how this class did. Let's see, live dashboard. Okay, this class had, was all right. Not as many hundreds in that one. Okay, here's yours. 759 722. I hear my fish. There you go. But, all right, guys, go do it. Let me know if you need help. I'll come by. Guys, you do have to write some of them down. You're not going to be able to do it in your head. So write down what you need. I'm putting the compasses and the rulers over here. You're going to turn in your papers when you're done. You don't have to staple them or anything. Just make sure you leave on the first one. I do. You'll need it for your quiz, though. Probably. I put some squares on the board. If you need your phone for the calculator, it's okay. Obviously, you can use your computer too, I guess. Whichever. Oh, you don't need it for your quiz?
Oh yeah.
I thought so. Oh, it got loose? Yeah. See, they don't work when they're loose. Horrible, huh? Trying to make them work. Oh. Oh, I broke the pencil. Always working, man. Just keep me busy. Gentlemen, let's get 100. There's a really easy 100 today. Come on.
Mr. Can I use your scissors?
Of course. Oh, sorry. I thought they were in my. Thank you.